Hello and welcome back. Let's solve some equations. Not just any equations, but let's put a few equations together and figure some things out. So we've got a long example written here, but basically what we're doing is we've got a hotel company. They want to put a new hotel in somewhere, but they only have $3 million in total. And so they this money will be spent on 30 rooms that they will be putting in the hotel, and one pool and one lobby. So what we can say is that the price of the pool, P, I'll make this a little bigger, plus the price of the lobby, plus the price of 30 rooms is going to equal 3. 3 million, but we're just going to say 3 to cut down on our numbers here. Furthermore, the pool and the lobby combined should cost the same as the price of all the rooms. So the price of the pool plus the price of the lobby should equal the price of 30 rooms. Now I'm going to rearrange this and put it right here. P plus L minus 30R equals 0. Same thing. Lastly, they want the pool to be half the price of the lobby. So the price of the pool is 1/2 of the lobby. I'm going to rearrange this. 2P equals L, or 2P minus L equals 0. We'll put that here. 2P minus L, we'll leave some space because we don't have an R in this one, equals 0. Okay, so we have a system of equations here. And based on our knowledge of matrix algebra from the last video, we can actually set this up as a set of matrices. What this will be is our coefficients. We call this our coefficient matrix, which is 1, 1, and 30, 1, 1, and negative 30, 2, negative 1, and 0. That's why I left a space. There is 0 R's here, if that's how you want to think about it. 2, negative 1, 0. And how we make this in a term of these variables is we multiply the matrices together. And so this will give us basically this as a matrix, but we don't really want to solve it that way. It's a lot easier if we just have numbers. And we can say that this equals our right side. 3, 0, and 0. So now, you may remember from the first video, we talked about augmented matrices. So we can actually represent this as 1, 1, 30, line, 3, 1, 1, negative 30, 0, 2, negative 1, 0, 0. And we can perform some things on this matrix. What we can do is we can multiply rows, we can add rows together, and we can add multiples of rows to another row. And so really all we're doing here is, as you might remember when you did regular systems of equations, I believe you would have did it in high school, although I do not know who's behind the screen watching me right now. You would realize this is really the same thing. Say if I was to subtract this equation from this equation, I would get 0, 0, negative 60R equals negative 3. and we'd be able to get the price of the rooms. But we want to do it in a simplified form like this, because what if we had 5 equations and 5 variables? That would get really messy. You might not even be able to fit it on your page. But you could fit it in with a matrix. Of course, these are pretty similar in size, but it is slightly smaller. And we don't have to worry about keeping our variables everywhere, and you know. So this is what we get. What you're going to want to do now is get it into a form where we have numbers here, and these 3, these 2, and this 1, and all of these is 0, so that we can solve for one variable, then plug it into this, solve for that second variable, then plug both of these into this, and solve for that third variable. So let's get it into that form. First thing we can see is I can do what I just talked about. I can subtract the first row from the second row. So I'm going to do that. What we're going to get is the same thing on top, but now we're going to subtract this from this to get our new second row. So 1 subtract 1 is 0, same thing here, and negative 30 minus 30 is minus 60. 0 minus 3 is minus 3. Now let's get rid of this 2. Well, what we can do is we can subtract 2 of this first row from our third row. And so what you want to do is you want to use the same row to get rid of the rows below it. You will call these pivots, maybe. I know that's what we call them, especially in the next thing that we'll talk about. But let's get rid of this 2. So let's subtract 2 of these from this. So of course we'll get 0 here because that's our aim. And now we've got negative 1 minus 2 of these, which is 2. So negative 1 minus 2 is minus 3. And 0 minus 2 times 30 is minus 60. Easy stuff. 0 minus 2 threes is minus 6. Now what I'm going to do here is, it's a very, you might not see it at first, but hopefully you'll notice. We now have our form. It's just a little messed around. So I'm going to swap these 2 rows. What I'm going to get is 1, 1, 30, 3. Swapping these rows, I get 0, minus 3, minus 60, minus 6. And I get 0, 0, minus 60, minus 3. And so we essentially have our answer here. What I'm going to do for viewing purposes is just get rid of this and this. And now we see what we have here. So this third variable here will be r. As we remember from our matrix multiplication, this row is r's, this row is l's, and this row is p's. Since if we add these together, we get 1, 1, 30. That came from our p's, l's, and r's. Where, of course, p is the price of the pool, l is the price of the lobby, and r is the price of one room. So let's solve for r. Negative 60r equals minus 3. We get that just from down here. Since we have all zeros, we can just solve for this. And so that's the magic of this. And by the way, this is called Gaussian Elimination. If you watched my Calc 3 series already, which I wouldn't expect, considering you need to know a little bit of linear algebra for Calc 3, but hey, we all have our own learning strategies. If you've already watched that, you know what, I forgot what I was saying, but we'll just hop into this. R equals 3 over 60. So R equals 1 over 20, which is 0.05. Easy. So now we know R. Let's find L. From here we get negative 3L minus 60R equals minus 6. R is 0.05, so this term here will actually become, what will this become? I should know this. It will become 3. So what we'll get is we will actually get we're going to get 3L equals 3. And you know what, I remembered what I was talking about with Calc 3 was you might have heard of Gauss's theorem, otherwise known as the divergence theorem. I was wondering, seriously, what could I have been going on about? But basically, L equals 1. And we do the same thing. I'm not going to go over it because it's going to be very time consuming. What we're going to get is that P equals 0.5. And so basically all we're saying here is that we're going to spend 1/20th of $1 million on each room, which is just $50,000. We're going to spend $1 million in the lobby, which that's a lot. And we're going to spend $500,000 on the pool. And let's just go back. We had that the pool and lobby combined should equal the same amount as the rooms. And so the pool, $500,000, and the lobby, $1 million, is going to equal to $50,000 times 30. Now we also know that our budget is $3 million. So if we're spending that, we could have also taken it off the bat that P plus L equals 1.5 because that's half of the budget. Anyways, some things you're going to check out. You could go through the word problem, or you could use this clever trick. So let's write our solutions here. P equals 0.5, L equals 1, and R equals 0.05. And let's take a look at what we have right here. Well, we have this equality. And so for this to be possible, let's just replace our P, which is 0.5, our L, which is 1, and our R, which is 0.05. And check if this equals 3, 0, 0. Truth be told, it does. I'm not going to go over this because we did talk about this in the last video. If you want to check it for yourself, go ahead. But that's Gaussian elimination. In the next video, we will talk about a much better, maybe more time consuming, but depends on the situation, a much kind of different way to solve these systems of linear equations. Thank you for watching.